Alright, this is Chapter 3, Lesson 1, Fractions and Decimals for Silver Math. So, when we're writing fractions as decimals, some fractions like 1/2 and 3/4 can be written as a decimal by making equivalent fractions with denominators of 10, 100, or 1,000. However, any fraction a over b, where b cannot be 0, can be written as a decimal by dividing the numerator by the denominator. So, a over b equals a divided by b. The decimal form of a rational number is called a blank blank. If the repeating digit is 0, then the decimal is a blank blank. In those two blanks, you're going to write repeating decimal and terminating decimal. The decimal form of a rational number is called a repeating decimal. If the repeating digit is 0, then the decimal is a terminating decimal. Alright, as you can see, there are two methods in order to figure out how to find the decimal of a fraction. Okay, so I can either use paper and pencil to write 7/8 as a decimal, or I can plug it into my calculator. When you do this, you do 7 divided by 8 and you hit the enter button. You get 0.875. You can also do long division. When you do that, when you divide all the way through, you get 0. Division ends with the repeating digit is 0. Okay. Not all fractions have repeating decimals that are 0. Sometimes a non-zero digit or a group of digits repeats without end in the quotient. So, if we look at 1/6, for example, if I divide 1 divided by 6, I get 0.16 and it repeats. Now, if you look at it on a calculator, it'll say 0.1666666, and at the very end it'll say 7. So a calculator automatically rounds up when you're dealing with decimals, but that 6 would continue on. Okay? You can indicate that a digit 6 repeats by annexing dots. So 1 over 6 equals 0.16666, and then the dots afterwards, that's called annexing. This decimal is called a repeating decimal. Repeating decimals have a pattern in their digits that repeats without end. Blank blank is a bar or line placed over the digit or digits that repeats. So in that blank, you're going to write bar notation. So bar notation is a bar or line placed over the digit or digits that repeat. The table shows some examples of repeating decimals and their bar notations. Okay, so you can actually see from this chart right here, 0.1 with the 6 repeating, I have 0.1 and the bar is over the 6. It's not over the 1 and the 6, it's just over the 6 because the 6 is what is actually repeating over and over again. 0.3535, you can see that the 35 is what's repeating. So 0.35, the bar will be over both of those numbers. 12.6 and the 8's repeating, so I'll have 12.6 and a bar over the 8. And then I have 5.714285, 7142, 71428, 7142885. The 714285 is actually what's repeating, so that's what goes underneath the bar. Alright, so we have two examples. It says write each fraction as a decimal, use a bar to show a repeating decimal. So 5/12, I do 5 divided by 12, 12, which gives me 0.416, and the 6 is what's repeating. So I write it as 0.416 with the bar over the 6. Negative 2 11ths, so I divide 2 divided by 11, I get 0.1818. The 1/8 is what's repeating, so that's what goes underneath the bar, and it's a negative, so a negative sign out front. Okay? You can either divide them the long way, or you can use a calculator. Either way works. All right? When you're comparing fractions and decimals, it may be easier to compare numbers when they are written as decimals, because that way you can actually line up the decimal and add any zeros that you might need. So in this example, I want to replace the dot or the circle with either less than, greater than, or equal to make a true statement. So I have 1/4 and 0.2. 1/4 I changed to a decimal, so 1 divided by 4 is 0.25. 0.25 compared to 0.20, because I'm going to add that 0 at the end, it's a placeholder. 25 is bigger than 20, so I'm going to put a greater than sign in there. You can also see on my number line 25 is bigger. So since 0.20 is to the left of 0.25, number line 1/4 is greater than 0.2. For letter B, -5/8 and -6/9. Okay, so again, I changed both of these into fractions. -5/8 is -0.625, and -6/9 is 0.6 repeating. Okay, so that means -0.6 is further on the negative side, which means -5/8 is bigger. It's actually closer to 0. Remember, when you're dealing with negative numbers, you want the number that's closer to 0. Okay? So when you're ordering from least to greatest, remember you have negatives. The larger negative numbers are on this side to 0, and then larger positive numbers. Alright, there are a couple try it out problems below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. Alright, now that you've had a chance to try out the try it problems, let's go over the answers together. So the first try it problem I have is letter A. It says write the fraction as a decimal or a mixed number. So I have A 7/20, so I want to go ahead and divide 7 divided by 20. Okay. I can just put this in a calculator, which is what I'm going to do. So 7 divided by 20 equals 0.35. For letter B, it says write the fraction as a decimal or mixed number. I have 5 3/4. Okay? 5 I'm going to ignore for right now. I'm going to go ahead and solve the fraction, which is 3/4. So that's 3 divided by 4, which is 0.75. And I just add this 5 out front. So I get 5.75. For letter C, write a fraction as a decimal or mixed number. I have -1/40. So when I divide 1 divided by 40, equals 0.025. And it's negative, so my answer is going to be negative as well. So -0.025. Alright, for letter D, it says fill in the circle with less than, greater than, or equal to make -5 5/9 and -5 1/9 true. So I have -5 5/9 and -5 1/9. So looking at these, they both have a -5 out in front. They both have a denominator of 9. So I want to figure out which one is closer to 0. Well, one's closer than 5, so that means -5 1/9 has to be bigger. For letter E, fill in the circle with less than, greater than, or equal to for 5/6 and 7/9. Okay. So I can either change these to a decimal, or there is actually another way to do it. You can actually multiply across. So if I multiply 9 times 5 is 45, and 6 times 7 is 42. 45 is bigger, so that means 5/6 is bigger than 7/9. So it's actually a shortcut. You can still change them to decimals. If I do that, 5/6 is 0.83 repeating, and 7/9 is 0.7 repeating. 0.83 is bigger. Letter F says in a second period class, 37.5% of students like to bowl. In a fifth period class, 12 out of 29 students like to bowl. In which class does a greater fraction of students like to bowl? So I have 37.5% and then I have 12 out of 29, so that's the fractions that you're comparing. 37.5% is 0.375. 12 divided by 29 is 0.41379131. So 12 29 is bigger, so that means the 5th period class. Alright, for letter G, on his first reading test, Trey answered 26 out of 30 questions correctly. On his second reading test, he answered 34 out of 40 questions correctly. On which test did Trey have the better score? So I'm looking at 26 over 30 and comparing that to 34 over 40. Okay? So you can either multiply them through or find the decimal. If I multiply, I get 26 times 40, which is 1040, and then 30 times 34, which is 1020. So 26 out of 30 is better. This is 0.86 repeating, 0.85. So the 26 out of 30 is actually the better score. For letter H, it says write the decimal using bar notation. I have 0.2424 repeating, so I'm going to write it as 0.24 with the bar over the 24. And then for letter I, it says write the decimal using bar notation, negative 2.8143143143. Okay, we can see that the 143 is what's repeating, so we write everything down up to what's repeating, which is a negative 2.8, and then we write 143 with the bar across the 143. Okay. You don't want to include the 8 because the 8's not what is repeating in this problem. And that is the end of chapter 3, lesson 1.